Hello, and welcome back to Destroy Planet Podcast with me, your host, Jack Gold. So today I'm joined by Christine Ward-Paige from Nova Scotia, who set up eOceans. She's telling us a little bit about her work. So first of all, Christine, welcome. Thank you so much for giving us some of your time. You start by telling us a little bit about your background.
Okay, I'm Christine Ward-Paige. I'm the founder and CEO of eOceans. I'm a scientist. I've been a scientist for over 20 years, so since the 90s. Um, and I, just like many of your listeners, I'm sure that most people will resonate with the fact that there's a lot of problems in science, policy, and management. And so that's something that I've been wanting to fix to make everything move smoother, more collaboratively, and so on. If that's a good, yeah.
Yeah, excellent, fantastic. Okay, so let's jump on from there. So tell us about the challenges that eOceans was set up to solve.
Yeah, so I worked, as I mentioned, I worked as a scientist in academia for many years, looking at fisheries, endangered species, pollution, and a variety of other things. And then I worked in academia. I mean, I worked in government, I worked for NGOs, I worked for industry, and I found that we were just continuously always behind. So the time a paper gets published, it's already years or even decades too late for policy and management to take place. And so, as a data scientist, as a quantitative ecologist, we kept analyzing data for one question at a time. So, I'm sure you and many of your listeners will resonate with that. You have a question, you develop a hypothesis, you either go out and collect data or you bring data together, then you write thousands, if not thousands of lines of R code, and then you point and click and make some GIS maps. Then you write a report, and then you send it out for publication and cross your fingers that someone will accept to review it, and so on. So it just means that we're consistently out of date for all the rapid changes that are happening in the world and in the oceans, in coastal ecosystems, on land, and so on. And then there's another issue that comes up with that, which is that those delays allow for misinformation, disinformation, and a lack of trust to get in the way. And then it creates conflict. And even violence in some cases. And so, regardless of where I was working, it was the same thing everywhere. So, for example, people love manta rays, big, charismatic manta rays. People want to fly around the world to see them in just a few places in hotspots where they are. And so alarms rang when they started to disappear in some of those places. And so they were proposed to be listed on CITES, in regulate endangered species trade, essentially. But there wasn't the data to support that international trade was threatening them. So that's when I was solicited to help. So crowdsourcing, I set up a global survey from people around the world. So we gathered 600,000 observations in 90 regions of the world. Where do you see manta rays? Where do you see them being fished? Where do you see them being sold in the markets? And then we compared that to the report. So every country is supposed to report what they catch. And only 2 countries reported catching them, but people were seeing them being caught and sold in markets around the world. So that discrepancy helped them get on the endangered species list in 2013. But what's happened since then? Has that been effective, And so the way science works is just in these very short snapshots. They're all out of date. And why can't that data now come together and be reapplied to the design of marine protected areas for understanding fisheries and so on? The problem with that is that there's ethical considerations. So someone gives me data, I have data for a purpose. And so especially when you're crowdsourcing, I bring in data and then I essentially own that data. And if people ask me for that data or someone wants to repeat that study afterwards, is it on me to decide who gets access to the data afterwards? So now I'm a gatekeeper. And it's, oh, I'll give it to my friends and people I know, but not to the people who I don't know. And so there were many of these issues in science. So science, I looked at it, science, management, and policy, the whole string of it. is that it's too slow, it's too expensive, it's too siloed, it's too manual, and it's really not an ethical way of moving forward, especially with our rapidly changing planet. So that is what we're aiming to do with eOceans, is to, I left my government job a few years ago. I was evaluating a time area closure. So it's like a type of marine protected area that was designed to protect cod. So cod, North Atlantic cod was super abundant. Communities and economies were based on that one species, but it collapsed. And so we've put in these tiny little boxes to say, oh, let's protect them here and there when they're spawning. And so that strategy had been in place for over 10 years and no one had ever evaluated, is it being successful? And so, I think it was a $700,000 grant to come in and evaluate, was this being successful? And then we found out very quickly that it hadn't been. And I thought, we've got these protected areas and these fisheries management strategies all around the world. This is one of the most heavily funded, heavily studied species, and we still didn't know that it's not working. How are all these other countries going to keep pace? And so that's when I left my government job to start to reinvent how we work as scientists, as policy, and not just science and policy and management in this sort of ivory tower, but how do we make it more collaborative with stakeholders and rights holders all around the world? So
See.
that's the
Yeah, goodness, what a mess. Oh, wow. Okay, well, I think that,
it's a mouthful.
yeah. So
But
okay, well, brilliant. So that ties us in, well, not brilliant, but the next bit's hopefully going to be brilliant. So that ties us in nicely to eOceans, and how does it work?
so how does it work? So it's a cloud-based platform where with cloud computing, so we have experts analytics all built into the back end. So you design your project where you say, I'm interested in this study area, and it can be anywhere in the world. You put up a geofence, it could be your nation, it could be your EEZ or your economic exclusive zone in the ocean. It can be a country, it can be an entire ocean, like the Indian Ocean, let's say, or the Mediterranean Sea. And you define your study area, that's the coordinates that this study is interested in. Then you decide on what variables you're interested in. So if you're only interested in tuna, you choose tuna. If you're interested in all fish, you choose fish, rhinoceros, whatever it is, you choose your species or your threats. So if you're interested in plastic pollution with tuna, then you can have those. And then the human dimensions too, because if we have biodiversity data separate from human data and separate from pollution data, it makes it really hard to look at things in a holistic way. So putting it all in one place, the ecological, the social, the anthropogenic, and the environmental variables all in one place, it means we can easily interrupt. I think we have over 1 billion variable options, combinations to choose from. And then you choose your analysis. So we've put in the most common analyses that people do, like catch per unit effort, biodiversity, species richness, frequency of occurrence, and so on. So essentially, no one should have to ever write that code again. And so it's done once, and now you just say, I want to apply it for this location, this species, and this data set. So the data sources can come through a mobile application. So if you're out in the field and you're logging data, whales, whatever it is, you log it through the mobile app. As soon as you upload it, it goes automatically to the projects. If you have existing data sets, you can upload that as a CSV file and it automatically goes into your project. Or if you want, we can custom build an API if you have data sensors and so on. So essentially all those different data sources come in and then it automatically generates your maps, your graphs, your reports based on the data that you've set up at the beginning. So the way that I see it is that science is now can actually be iterative instead of these slow, static, outdated reports. And it's iterative, but in this very, stagnated, siloed way. It just becomes this iterative and ongoing way. Yeah.
Fantastic. And what is the current scope of it? Is it just still within Canada, or you managed to grow abroad?
No,
How big
so
is
it
it?
can work anywhere. So like I said, you put it when you're creating a project, you're uploading the geofence and that sets your area. So we have projects in the Maldives, South Africa, California, and in Canada so far. Yeah.
Brilliant. Okay, and could you give us some examples of some successful case studies where this has been implemented? You've alluded to a few just there.
Yeah, great. So I would back out a little bit, and before we even wrote the first lines of code, we did this all manually. So, like I said, the manta ray project was done manually. We ran the Great Fiji shark count. So, how does we really drilled into how the data are collected? How do we clean it? How do we analyze it over and over and over again? So that was done before we started even built the app. So like 10, 15 years of work was done before designing and building the app. So now with the app, we've got in California, we have a marine protected area. So it's designed and run, the project is designed and run by Ocean Science Analytics, a company in California that wants to evaluate the success and the health of the marine protected area, the La Jolla, California Marine Protected Area. It's right off Scripps Institute of Marine Science. And so they are looking at biodiversity, social values, and the threats to that area. So even last week, there was a domoic acid poisoning event where people are reporting dead mammals like dolphins and sea lions. And other times it's really exciting to go in and you see hundreds of leopard sharks or and squid, when the squid lay their eggs, it's just like looks like snow underwater. So every day when I wake up and I follow that project, I get to see all the differences. Then in the Maldives, it's a team of scientists that are working out of Six Senses Luxury Resort. So they're a team of scientists with the Maldives Underwater Initiative, and they're studying megafauna, turtles, whales, dolphins, sharks, and so they're gathering that data, and that data has actually been used already to help implement a Mission Blue hotspot. So Hope Spot, sorry, Hope Spot. And so that helps get increased awareness and tries to get that area to be increased for conservation and protection. And the third one that I would give as an example was in South Africa. And this is one of the first ones that started as like a beta testing pilot project. It was a youth, so a young woman in South Africa who lives right on the Utukela Marine Protected Area, right on her coastline. And she said she was concerned about the ships coming through the Marine Protected Area. They're not supposed to be in it, but not cruise lines, but actual ships like that are transiting through, and they come through the protected area at the same time that humpback whales are migrating up. So she was out there logging every day and which ship, and then she'd use AIS to figure out who owns that ship. So she would tag that ship, and then she'd have the breaching humpback whale right in front of her. And and she won a slingshot award, a National Geographic slingshot award, which brought her, it's kind of like the teen version of the Earthshot Awards, and took her to the Earthshot Awards in the fall. So yeah, so lots of different ways to be using the platform for sure.
Fantastic, brilliant. Okay, good stuff. And so tell us about as it's expanding, what are some of the challenges that you're currently experiencing?
Um, I guess challenges are now are getting the word out. So it's getting the word out, but also science has really been unchanged since the 1700s. So it's
Really?
never been changed, right? It's always followed this linear process. Metrics of success are the numbers of papers you publish and whether or not it goes into this journal or that journal, not necessarily how much impact it actually had on the world, on people, on policy. And so I think changing those metrics of success is a challenge for people who are stuck in the old ways. And so, yeah, so we're trying to find those people that are innovative pioneers that are trying to really are in science management and policy to make a difference, not just for like that career check boxes. So anyone who's working on in your audience, potentially for the Horizon Europe funding, which are solving some of the world's stickiest problems, that's when eOceans can come in. If you're working on open science, on things that are just like really impacting people and the planet and biodiversity in a real-time way, those are going to be the projects that need to adopt eOceans.
And so you're describing that the current methods or the very long-standing, centuries-old methods are little bit very confined. So what would be some of these alternative metrics of success?
The alternative metrics of success, the way that I envision it is, imagine you start a project. So I study manta rays, right? So, or sharks, or we did the 100 million sharks die every year paper. And so we start a project on sharks, but imagine how many other projects get spun off from that one project. So by collaborating with 50 other projects versus um, more collaborations would give you a higher metrics of success, more impact. So the number of spin-off projects that are come from that project that you started, and also the number of engagement. So we also, in the platform, we measure engagement. So imagine a project that has people from around the world that are engaged in that project and following it and learning from it. Then you can actually measure how much impact you've had in these previously more softer ways that now we're measuring it quantitatively.
Yeah, and so what's the potential for growth?
The potential for growth is pretty good. I mean,
Yeah,
yeah.
yeah, all the way. Yeah.
Every day when I read the news, I sign up for so much different news in biodiversity, on marine heat waves, on rewilding. I see the picture behind you, all these projects that are being put in place for nature-based solutions, biodiversity credits, whatever it is. How do we make them go faster? How do we make them accountable or allow them to be accountable? So it really is. I think when I read the news, I think, oh, it could be applied there, 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 there. And so, yeah, every day I find that I'm seeing new opportunities of where it could be used.
Great. And speaking to the sector more broadly, even if it is quite a sector at the moment, are you sort of really feel like you're the only game in town at the moment, or do you see things sort of popping up different parts of the world and different you know studies, universities, scientists? How do you see the general sort of spread of these things across the rest of the industry?
Yeah, I mean, in South Africa, we're talking about just the ocean side, looking at sea lions, looking at penguins, looking at all those, you know, individual animals, biodiversity, sort of from a marine science perspective. But then I don't know if you've been following it, but in South Africa, there were these sea lion or Cape fur seal die-off. So there were lots of seals that were dying, or seals or sea lions, sorry. Um, and so they were been dying for the last few years and they didn't know why. And just last month they reported they did a biopsy and they found that it was rabies. So this is like the first incident. And so that's coming from the wild dogs on land. And that's a human vector and it's a human issue too. So you think now if they had a project on in the ocean for the rabies essentially in the sea in marine mammals, and then on land, and then one that crosses both of them, then you can start to intermix them instead of having, like we've always had, a continuous silos where it's just one project, one on sea lions, one on seals, one on penguins. It's now can just be, much more fluidly working together.
That's it. And so, how would you like to see things grow? Where could we be with eOceans in, say, I don't know, 5, 10 years, where things keep going and growing as they are?
Yeah, so I would foresee them being used across fisheries, even hunting on land, rewilding. So as you're starting to do these different management, invasive species, everywhere I go, it would be great to cover the world many times over. So, and that's another piece that I don't know if I've covered yet, is that when you create data currently, it just gets used for one purpose. With eOceans, we want it to be highly collaborative. So if you're collecting fisheries data on mackerel, let's say, And that data, then you see invasive species or you see endangered species along that way. Now the data can then feed all these different projects instantly. And so this way it all works together. And ideally, the way that I see it is that we start to set goals, not just a moratorium on cod or grouper or whatever it is. You actually start to set goals, and those can be recovery goals or sustainability goals, depending on where you're at. If something's been depleted, it needs to be a recovery goal. If something's still good, it needs to be a sustainability goal. And then have all the different stakeholders and rights holders and projects all working together towards that same goal. And that includes fishers. Fishers are feeding people. So we need to think about them as part of the solution and getting them into the same space. So, when I was first building the app, I saw that, I mentioned that there's different apps for different silos, but enabling them to come together in the same place so that the whale watching and the lobster, everyone can be working together was really key in my mind to being able to actually set goals and work towards those goals together.
Well, quite the vision. And finally, Christine, where can people find you if they want to get involved and see what eOceans is all about?
eOceans.org, or yeah, eOceans.org, and that's where we have all of our information. You can download the apps. So if you're by the ocean and you can start to log animals that you see or any pollution or human activities, then you can do that. We only have citizen science projects for the ocean space right now. And so you actually have to be there. The location of your phone tells eOceans where to send the data. So everything is in situ. So I just need to make that clear. And then yeah, if somebody is wanting to start or currently running a project and doesn't know what to do with the data, then get in touch with us.
That's it. Christine, thank you so much for your time.
Thank you.